We all think we know what heat feels like. But it turns out the deadliest heat waves we've seen so far, they've mostly been dry. Now, a new and frankly a much more dangerous kind of heat is on the rise, and it's one that can push the human body past its absolute survival threshold.
Yeah, that quote right there, it perfectly captures the danger we're talking about. These are extreme humid heat waves, what scientists call wet bulb events. And they are one of the most frightening consequences of climate change because they can literally neutralize our body's amazing natural ability to cool itself down. To really get why, we've got to first look at the two basic kinds of heat. Okay, so on one side, you have dry heat. This is what most of us picture when we hear heat wave. It's driven by these massive high-pressure systems that just park over a region and compress the air, heating it up like an oven. Think of that insane heat dome over the Pacific Northwest in 2021. But then, on the other side, you've got humid heat. This is a totally different beast. It's driven by one thing, a massive amount of moisture in the air. As our planet warms up, the atmosphere can hold more and more water, and that makes events like the deadly 2015 Karachi heatwave far more common. The real danger is all about how we cool ourselves down. We sweat. But here's the problem. When the air is already completely saturated with water vapor, your sweat has nowhere to go. It just can't evaporate. And when that happens, your body's built-in air conditioning system just shuts down. And that's exactly when a heat wave turns deadly. This all leads us to a really critical scientific idea, the wet bulb limit. It's basically a measurement for when heat becomes, well, literally unsurvivable for humans. So, what in the world is a wet bulb temperature? It's not your standard forecast, that's for sure. It's a special measurement that basically mashes together the air temperature and the humidity into a single, powerful number. Think of it as the true, real feel for your body's ability to cool off. The easiest way to wrap your head around it is with this simple wet sock analogy. Seriously, imagine you take a thermometer and you cover the bulb with a wet sock. As the water evaporates off the sock, it cools the thermometer down. That's exactly how sweat cools your skin. But if you're in really humid air, very little water can evaporate, so the thermometer stays hot. That final reading, that is the wet bulb temperature. It's a direct proxy for how well your body can shed heat. This brings us to a crucial threshold that scientists call the limit of compensability. It's a fancy term for a simple, terrifying idea. It's the point of no return. It's when your body officially loses the battle against the heat. Sweating doesn't work anymore, and your core temperature just starts to rise and rise and rise uncontrollably. So what is that limit? Well, for older adults, research shows the danger zone can kick in at a wet bulb temperature of just 19 degrees Celsius. Now, I know what you're thinking. 19 degrees sounds amazing, right? Like a perfect day. But that's exactly what makes this measurement so tricky and so incredibly important to understand. Because, and this is the key takeaway, a 19-degree wet bulb temperature is not 19 degrees on a regular thermometer. It could mean a scorching dry heat of 46 degrees Celsius, that's about 115 Fahrenheit, or it could be a much cooler 32 degrees Celsius, but paired with extreme, suffocating humidity. Either way you slice it, the stress on your body is exactly the same. Okay, so we've got the science down, but where on earth are these deadly conditions actually showing up? And who is going to be most at risk as things get hotter? Well, if we hit 2 degrees Celsius of global warming, a milestone we could reach in just a few decades, about 35% of the Earth's land area is going to face these dangerous wet bulb conditions, a third of the planet. And if we let warming get to 4 degrees, that number jumps to over 60% of the planet's landmass. And that 35% isn't just empty land, not at all. We're talking about some of the most heavily populated places on the entire planet. Most of India, huge parts of China, and even the eastern United States all fall into this high-risk category at just 2 degrees of warming. It's also about how often this happens. You might remember the deadly 2003 European heat wave. That was considered a once-in-a-century event. But at 2 degrees of warming, scientists project that a heat wave just as bad could hit a city like Paris every few years. What was once a rare catastrophe is on track to become a regular part of summer. So if our own bodies can't protect us, what can? Well, that brings us to our main line of defense and to its central, massive paradox, air conditioning. The hard reality is, once you cross that wet bulb threshold, shade and water just aren't enough. The only way to get your core temperature down is to physically cool the air around you. This makes air conditioning our absolute last line of defense, but it is a deeply, deeply flawed one. Right now, AC accounts for about 3% of global greenhouse gas emissions. And you might think, okay, that's not so much, but here's the thing. The International Energy Agency expects the number of AC units worldwide to nearly triple by the year 2050. This creates a gigantic surge in energy demand, right when we need to be cutting back like crazy.
And that's just one piece of the puzzle. AC is expensive, which means it's often inaccessible to the world's most vulnerable people. It also just pumps heat from inside to outside, which makes the urban heat island effect even worse in our cities. It puts huge strain on fragile electrical grids, leading to blackouts. And of course, it directly fuels the very warming that makes it so necessary in the first place. It's a vicious cycle. Now, imagine for a second how these problems can overlap. Picture a powerful hurricane slamming a city, knocking out the power grid for a week. And it's immediately followed by a deadly wet bulb heat wave. Suddenly, the only defense people have, air conditioning, is completely gone. That creates a truly catastrophic situation. And these compounding disasters are a huge and growing concern.
So what's the answer here? Well, this whole AC paradox is a pretty powerful argument that we need a multi-layered approach. The only real way to meet this growing need for cooling without making climate change worse is to power it all with clean energy. But beyond that, we have to redesign our cities. We're talking green roofs, way more trees. We need to build public cooling centers for people who don't have AC. And we desperately need to upgrade our power grids to be more resilient.
Look, we are absolutely heading into uncharted territory. Let's make no mistake about that. But this quote reminds us of the most important thing of all. We still have agency. Our choices today will directly decide how severe these future heat waves are going to be. Which really leaves us with this one final critical question. As the world gets hotter and hotter, how do we design a future that can protect everybody without just adding more fuel to the fire? That is the defining challenge we're facing right now.